Good afternoon and welcome to CFA UK's Wednesday webinar at 1. My name is Gerhard Sobel. We're delighted to welcome Wenzi Chen to present on Beyond Bitcoin, Digitalization of Space Using Blockchain. Bitcoin, or any other cryptocurrency, is not all that matters when the subject is blockchain. Today, Wenzi will briefly explain the buzzword, blockchain, how it works, and what issues it solves in the real world. We will look at the specific application in the digitalization of space using blockchain with a focus on two implementations, namely car parking management and shipping container management. Ultimately, the digitalization process will transform commercial space into a commodity, which carries similar traits as any other commodities that are invested and traded today as financial products without the need of physical delivery. Wenzi is Managing Director of Altarius UK Limited and Head of Market Development for Altarius Group, a financial service company that provides fund solutions for both traditional assets and crypto assets. Altarius partners with Ecosystem Technology provide advisory as well as technical support to enable the use of blockchain in various industries. Wenzi started her career in Singapore in 2009. Her last role was an equity research analyst at DBS Bank, covering the real estate sector. Before that, she worked at EFG Asset Management and HSBC Private Bank. She developed her interest in financial technology and joined Altarius last year to mutually develop the new business line in crypto and blockchain-related assets. Wenzi graduated from the University of Auckland with a bachelor's degree in commerce. She's a CFA charter holder who has volunteered at CFA Singapore and now volunteers at CFA UK. The presentation will take about 30 minutes, followed by Q&A. Please participate in the Q&A session using the appropriate box on your screens, as it is not every day we have Wenzi here with us. Wenzi, over to you.
Thank you, Gerhard. Okay, good afternoon, everyone. It's my pleasure to give a presentation and on the huge buzzword of blockchain. My background is not in mathematics, which means I'll focus on the application of the blockchain technology, and we'll see how it's can be used in real case. Okay, so we have the agenda in front of us. We're going to talk about, roughly go through the structure of this webinar, and going to explain blockchain technology in simple words, and giving two usage in real life in the case of car parking and shipping container solutions, and lastly connecting the dots to show that how do we move from tech to fintech. Okay. In this webinar, we're going to, like I said, we're going to talk about the blockchain technology, the real case application in it. The application discussed in this webinar will be in the context of the Chinese market, where we partner with a blockchain developer to develop the two solutions. Whereas this webinar is not going to talk about the inner workings of the math behind blockchain, the difference between various blockchain networks, the regulations, and is not going to talk about cryptocurrency. Okay, blockchain has certainly become the buzzword in the last 2 years. But what it actually is, it is not easy to give a straightforward definition, but I'll try to give it a go. A blockchain is, in its simplest terms, a timestamp series of immutable record of data that is managed by a cluster of computers not owned by any single entity. Each of these blocks of data are secured and bound to each other using cryptographic principles. Well, now that's a mouthful, and probably we can put it more simply. Whereas a block can be understood as a record of digital information, and the chain is the database where such digital information is stored. But what does this actually mean? Step one in the blockchain is when you trigger a transaction and the network will verify the transaction. The graph shows that one party initiates a transaction as a money transfer, but in fact, this can be any transaction, such as an agreement to trade or a delivery of a service. Blockchain, as its name suggests, consists of multiple blocks strung together. In order for a new block to be created, that transaction must be verified. In traditional public records of information, there is a single authority in charge of vetting the new data entries, like a bank, a security exchange, a marketplace, or a platform such as Wikipedia or Facebook. With blockchain, however, the verification job is left up to a network of computers. These networks often consist of thousands, even millions of computers spread out across the globe. Each computer on the network is called a node. After the transaction is verified, we move on to step number 2. A block is made up and created. Blocks on the blockchain are made up of digital pieces of information. Specifically, they have 3 parts. Blocks store transactions information, like the date, time, and dollar amount. Blocks store information about who is participating in the transaction. Here's to note that the participant's real identity could be encrypted. And the blocks store information that distinguishes them from other blocks. This means that even if the exact participants make a duplicate and identical transaction, we can still tell the blocks apart from each other because of unique codes. This unique identification of each block is termed hash. We'll talk more about hash in the next slide. Once a block is created, after the transaction verification, the block is added to the blockchain. That is step number 3. The block is also given the hash of the most recent block added to the blockchain. Once hashed, the block can be added to the chain and the transaction is officially recorded. We spoke about the hash in the previous slide. The hash is a unique identification of each block, which contains all transaction information of the underlying block, the fact that the information has been verified, as well as unique identification of the previous block added to the blockchain. When that new block is added to the blockchain, it becomes publicly available for anyone to view. Now we'll explain what is a blockchain and how a newly created block is added to a chain. The natural next question is, so what? What makes blockchain so special? There are 3 distinctive pillars of the blockchain technology, namely decentralization, transparency, and immutability. It is important to note that even the single existence of any of these 3 pillars existed in previous technologies. The coexistence of the 3 pillars together did not exist in any previous technologies. And that's what makes blockchain technology new and cutting edge. We'll go through one by one. Pillar number 1, decentralization. We are very used to a centralized world of services. The idea is very simple. You have a centralized entity who stores all the data, and you have to interact solely with this entity to get whatever information you required. An example is Google search engine. You send your request, the central server processes your request and delivers information to you. There are countless other examples such as Amazon, banks, exchange, even Uber and Airbnb. Now, centralized systems have treated us well for so many years. However, there are several key vulnerabilities. Firstly, because they're centralized, all the data is stored in one spot. This means they are easy targets for potential hackers. What if the centralized entity somehow shut down for whatever reason? That way, nobody will have access to the information that it possesses. Worst case scenario, what if the central entity gets corrupted and malicious? If that happens, then all the data inside will be compromised. The blockchain is maintained by a peer-to-peer network. The network is a collection of nodes which are interconnected to one another. Nodes are individual computers which take input and performs a function on them and gives an output. The blockchain uses some kind of network called peer-to-peer network, which partitions its entire workload between participants who are all equally privileged, called the peers. This means there is no longer one central server. There are several distributed and decentralized peers. In a decentralized system, the information is not stored by a single entity. In fact, everyone in the network owns the information. In other words, the data is distributed, not copied. There is no one true copy of the database. That is why blockchain is a type of distributed ledger technology, or what we call DLT. We move on to the second pillar, transparency. One of the most interesting and misunderstood concepts in blockchain technology is transparency. Some people say that blockchain gives you privacy, while others say it is transparent.
Lindsay, can you give me a second, please? Hello, can everyone hear us?
Okay.
Thank you.
So we good? I don't
Yeah,
need to go through it again.
We're good.
Okay, so second pillar, transparency. Right. So is blockchain transparent or is that private? Why does it happen? Or is that secure? Well, a person's identity is hidden via a complex cryptography and represented only by their public address. So if you will look up a person's transaction history, you will not see Tom and Harry did what and what. Rather, you will see two complex serial numbers participated in a transaction. So while a person's real identity is secure, you will see all the transactions that were done by their public addresses. We move on to the last and the third pillar, immutability. Immutability means that once something has been entered into the blockchain, it cannot be tampered with. The reason why the blockchain gets its property is that of the cryptographic hash function. The blockchain is a linked list of block which contains data and hash pointer which points to this previous block, hence creating this chain. What is a hash pointer? Well, we will explain the hash before. A hash pointer is similar to a pointer, but instead of just containing the address of the previous block, it also contains the hash of the data inside the previous block. This one small tweak makes blockchain so amazingly reliable. I'll give an example. Imagine this for a second. A hacker attacks into a blockchain and attacks block number 3 and tries to change the data. Because the properties of the hash functions, a slight change in the data of block 3 will change the hash drastically. This means that any slight change made in block 3 will change the hash that is stored in block 2. And now in turn, the block 2 has its data changed, and the hash of the block 2 will change. This will result in the change in block 1, and so on and so forth. This means that a small change in block 3 will entirely change the entire blockchain, which is impossible. So that's we call this the avalanche effect, and this is how exactly blockchain attain immutability. Now we've covered how a blockchain works and what makes blockchain so special. I think it's enough theory today, and we can move on to real-world applications. How is blockchain applied? When we talk to real-world applications, and especially talking to participants in industries, one key thing that we need to face when explaining the technology to the participants, and it is something that I want to make reference to one of my all-time favorite movies, Fight Club. Because in real-world applications, the participants do not really care whether you use blockchain or a different technology. They want to ask that, what problem does it solve? Which means if we want to make use of blockchain technology in the real world, we have to abide to rule number 1 of Fight Club. Do not talk about blockchain. Focus on solving the problem. A key problem we face in business is communication and information sharing. People within the same organization, different parties within the same sector, or different participants across various sectors are not willing to share information, mainly due to cumbersome process, data security, and conflict of interest. Blockchain encourages the willingness of voluntary information sharing, and the blockchain connects the information islands. We'll see how this is achieved through 2 real-world applications, and we'll start with the car parking solution. In the evolution of car parking solutions, we see that how we have moved from car parking 1.0 to 2.0. 1.0, where we see the post-Internet of Things age, is the traditional way of parking. A driver needs to physically drive into the destination, look for car parks, and park their car. This means every car park is an isolated information item by itself, and no information is connected or shared. Whereas in the last few years, we moved into the Internet of Things, where the information and availability of car parks could be pushed into a cloud, and the cloud information can be accessed by the driver remotely without physically being in the car park. Sounds like a perfect solution to share all the information. The problem with this 2.0 solution is that it requires a centralized third party to matchmake the supply and demand. The issue we face is that smaller car parks do not want to share their customer information with larger operators in fear of losing their customer. And larger operators are more inclined to develop their own app and do not have the incentive to disclose the data to third parties who may make use of the data for other commercial reasons. So in 2.0 solutions, the cloud connects some of the islands, but make those centralized islands. And the larger islands do not grow and do not connect to each other. What is the solution now? Well, with blockchain technology, we introduce car parking solution 3.0. Because remember, one of the key pillars of the blockchain technology is decentralization. Blockchain provides a decentralized network, and the data is encrypted. It removes the concern of losing customer relationship, while at the same time allow information to be transmitted and the resource to be allocated more efficiently. And at the same time, there's no one single party possess all the data that is pushed on the blockchain network. Rather, all participants own the data equally. Here I'm showing a chart about the blockchain-enabled car park solution infrastructure that we use in China. In very simple terms, we basically connect participating drivers, car parks, third-party platforms to one single network. Every party pushes their inquiry through their respective nodes to the network. The network will make calculation and match demand and supply. The major difference between such a blockchain-enabled solution and a traditional middleman platform is that, number one, while every participant has access to the network, no one owns the network. The processing and storage of the data of the network is distributed to all participants on the network. So this removes concerns over unforeseen or malicious behavior by third parties. Number two, even though everyone has full transparency of the traffic on the network, data pushed on the network are encrypted. So instead of seeing Tom is looking for a car park, the network shows a serial number needs a parking space. And that serial number represents the identity of Tom. Once the request is matched, Tom receives a notification on his mobile phone and can drive into, let's say, car park A with the scanning of a QR code or scanning of his number plate. However, the operating company of carpark A will not have the contact information of Tom. This proof of concept won an open tender in Guangzhou in China last year for building the first blockchain carpark solution system in China. And now we have more than 600 carparks that has been participated on the network in 4 cities in China.
On one single network.
On one network, yes. We move on to the next application for shipping container management. Before we talk about shipping container, I would like to take one step back, because the issues faced by shipping container operators are largely similar to as the issues faced in the logistics sector in general. Every day, there are $140 billion tied up in disputes for payments in the transportation industry. Blockchain provides transparency that reduces disputes. Processing and administration costs have risen to as high as 20% of transportation's overall cost due to over-reliance on paper transactions, where distributed ledger largely, if not fully, removes paper transaction costs. Organizations need updated, secure, and authentic data to make decisions. The transparency and immutability of blockchain provides traceability of the information processed on the blockchain. And blockchain also ensures trustworthy data across transportation and logistic ecosystem, since the entire network contributes to the data validation. Because of time constraints of today's webinar, and the topic is focused on digitalizing commercial space, we'll discuss only on the last point. It's about mismatching between demand and supply, and how do we allocate resource more efficiently. Blockchain encourages high voluntary participation of information sharing, which optimizes resource allocation. In the graph you see here, the dots represent a ship that carries containers. You can see that when the ship leaves port A, carries the container full of cargo. And then it will drop off cargo at port B and port C, and once it reaches its final destination, it becomes empty. What happens now is that this empty ship needs to move to somewhere else, probably back to port A or another port. And because we can't ship air in the ocean, in the fear of topping over the ship, usually water is injected into the containers, and this is called ballast. One of the major recurring costs of shipping is finding and repositioning empty containers. The problem has been enhanced by more complex shipping supply chains and the increase of containerization of traditional bulk cargo. To give an idea of the scale of the problem, the Boston Consulting Group estimated that repositioning empty boxes costs the industry $15 to $20 billion a year, equivalent to up to 8% of a carrier's operating cost. Empty containers made up a quarter of all box movement in China, 29% in Europe, 15% in the United States. 33% of the cost was due to carriers' operational inefficiencies. In another survey, maritime consultant Drury said that repositioning an empty container cost a ship line $400 per box. At the same time, you see while this empty ship is leaving port D, there are cargoes in the city where each port is located and cannot be shipped and waiting at the port. This is largely attributed to the fact that smaller shipping container operators do not have enough vessel capacity. Why does this happen? Well, large operators are unwilling to participate on third-party networks that can actually provide this mismatch, provide the matching of supply and demand. This is due to data protection concerns. As smaller operators do not want to feed their customer data directly to large operators who practically are their competitors. Now think about this. This misallocation of resource faced in the shipping industry is actually very similar to the problem that's faced in the car park industry, where resource is limited but also misallocated, and information is not shared. So now we bring you the blockchain network structure for shipping container industry. The graph looks more complex than it actually is. The key here is voluntary data sharing. You can see that all participants, let it be shipping company, truck company, the port platforms, will push their data through their own node into the blockchain network, and the algorithm on the blockchain network will allow optimal resource matching and allocation. And after which, the information will be fed back to the different participants, and they will act accordingly to allocate their resource. From a user's perspective, the truck company will fill in a form online. That's step number 1. And then the shipping company will generate a contract through a smart contract system on the blockchain network, which you see in the middle in green. And this smart contract will basically verify and send inquiries to different participants. All the process is paperless and recorded and processed on a distributed ledger. This largely reduced processing cost and improve allocation of resource. So now we talked about 2 real-life use cases, but we focus largely on tech. We want to connect the dots to see how do we bring tech into fintech in our financial world. This chart is invented by us, and we call it ABCD cycle. The cycle is actually not in strict order of ABCD, but we think it's cooler to put it this way. This is basically how information processed through the ecosystem. We can start with C, where the cloud of inter-organizational and sector data are gathered. And then we move to B, where the data is pushed into a distributed ledger and storage on the blockchain. The data is then cleaned, labeled, and standardized, and then can be used for AI analysis. After the analytics, the data become what's so-called the smart data, means it's actually carry useful information, and the smart data again will feed into the product design of the underlying participants of different clouds. And this will become a very benign cycle wherever participants in the blockchain actually benefits from data sharing to their product design. How do we connect the physical world into the real world? Where in the picture you can see, in the physical world, we use Internet of Things for data gathering, and blockchain enables digitalization and information mining, and bring the data into useful information. Well, blockchain solves the confirmation, traceability, and clearing of online digital assets and certifications. The key determination for the success of the real-world implementation of the blockchain application is whether it can be anchored on the credibility pivot in order to complete the settlement in the real world. And that's why the finance part of actually facilitating the settlement of the information processed on the blockchain network is essential. Otherwise, nothing will be delivered in the real world. After describing how we can help commercial space to more efficiently allocate the resource, here we talk about eventually we can bring commercial space into a commodity. Here we define commodity as a reasonably interchangeable good or material bought or sold freely as an article of commerce. There are generally four essential traits of an investable commodity. Interchangeability. The property of commercial space are inherently not interchangeable because of their different locations or different properties that they carry. However, blockchain introduced standardization of the commercial space, being it a car park or shipping container, and the space itself could become interchangeable. Tradability. The commodity has to be tradable, meaning that there needs to be a viable investment vehicle to help you to trade it, like a future contract assigned to it. Standardized and digitalized commercial space can be dissected into small units. Each unit will in turn can be packed as a financial product to introduce tradability. So instead of investing in the entire shipping container, if not a vessel, you can actually invest in a small dissected unit of a shipping container. Deliverability. Physical delivery of or cash settlements are possible. For cash settlements, a mark-to-market pricing mechanism is necessary, and this brings us to the next very crucial point, liquidity. An active market with buyers and sellers constantly transacting with each other will introduce liquidity. Liquidity is critical because it gives you the option to get in and out of an investment without having to face the difficulty of trying to find a buyer or seller yourself. Is there an active market traditional space as of today? The answer is most probably not. Having said that, we believe that the market should not rush into creating exchanges or secondary markets, as adoption is new as a financial product and the market depth is shallow. Nevertheless, we believe a secondary trading market is a natural product of a functioning commodity. It looks more like a chicken-egg problem, but we endeavor to nurture the growth of the underlying market first, digitalizing commercial space first, using the blockchain technology, and eventually, as the underlying asset grows to a certain depth, it will provide a healthy foundation to attract investors and then provide liquidity. At that point, commercial space will become a commodity. And that's the end of the presentation. You can reach out to me on the contacts here. And thank you very much. And I think we have some time for questions.
Thank you, Wendy. Thank you very much. Very enlightening. Question from Andrew. Are there any industries or companies that blockchain technology can disrupt?
I would say the answer is many industries. As a concept, if you think of any industry that is enabled by a third party or a middleman, and this is a very severe target for blockchain technology. And I'm not only talking about banks, but even the Uber and Airbnb, who are just growth in the last few years, are under threat of the technology.
Oh, thank you. I have a quick question here. You mentioned in various stages that blockchain encourages participation. How does it do that?
Okay, so in the case of, let's say, shipping container management, the large ship operators have invested huge amount of money in their vessels. And we explained the concept of ballast, that after they've offload their cargo, the containers become empty and they have to basically ship air or water around. If you give them a solution to optimize the use of the resource without at the same time compromising their operating efficiency, reduce their cost by remove the paper transactions and improve their profits because their other operators are using their space, then they are more willing to participate.
Thank you. Question from Andrew. Could the role of shipping brokers who match vessel owners with exporters be disrupted?
Oh, definitely. The answer is definitely. But what I want to highlight is that shipping industry or logistics in general is a very traditional industry. And with disruptive technology, it usually takes probably much longer than people expected it to disrupt the entire industry. But we start from somewhere.
But doesn't it look like that thing that it's going to take a huge time to happen, and when it happens, it happened all the way too fast.
Yes, but it doesn't really happen overnight. During the process, actually, a lot of actions have already been implemented. Yeah, for example, like our application has one of our clients is the largest shipping operator in China, and with that we can actually get access to more than 50 billion shipping container space that we can digitalize. But you're not going to digitalize all the space overnight. But maybe in a few years' time, they will be basically all the space will be digitalized and pushed on the network.
Thank you. A question from Rexy, I believe. Would monopoly companies prefer to live with inefficiencies for fear of blockchain eroding their market domination as they share their valuable information?
Very good question. I think this is one of the very key issues that was faced when I was explaining CAPA solution number 2, or even in shipping container, actually any industry that is dominated by large participants, the monopolies do not want to participate on any third-party network. They only want to develop their own network, and they want to ask smaller participants to tap on their network. Now, the key question is that blockchain actually can provide the participants the option to encrypt their data. So for the data that they push on the blockchain, they actually do not lose so-called their data is not vulnerable. And at the same time, like I explained, they will have spare capacities where at the previously, without the blockchain technology, they do not really see the incentive or the cost and benefit of pushing their data to a third party, which they may not trust, we're getting a small benefit. But now if we remove the third party and put their data on, encrypted data on a trusted network, and at the same time can generate more revenue to them, then that's what we call encourage their participation into the network.
Thank you. As you mentioned all of these issues concerning data, I was wondering whether the data protection rules that we have coming in and have come in and will come in even more, whether they help or hinder the use of blockchain.
Okay, I think I made a disclaimer earlier that I'm not going to talk about regulations because it's very different from country to country.
No, I don't mean to get into regulations, but do you think that there is a need and a clamor for more privacy and to the right to be forgotten, for example?
Yes.
So and when you're on blockchain, it's simply there. And you can't change it. So would you think that hinders or helps it, or is it too soon to say?
So everything, like I said, blockchain removes a third assigned party who possess the trust and then records all the data officially and in an immutable way, which means that all the transaction will become public information and you basically just can't change data. Is that something, like, for example, we're in the banking world that we would like to see? It depends on from whose angle. Maybe the organizations do not have a huge incentive to do that, but maybe the users have a better incentive to participate in that. And then you can see that actually disruptive organizations come into the industry, and previously they can't compete with the larger organizations. But now, if they can provide a service that feeds better into the user's demand, they probably have a better go.
So it really depends how you turn this. Thank you. A question from Andrew. Is there any industry where blockchain technology is being used today?
Oh, yeah. So that's what I said. The carparking industry, we are doing that in China. There's 600 carparks already signed up. for shipping container, we are in the basically protocol stage, but we have signed up 3 container operators. That pretty recently, the largest, I think it is the largest container operator, Maersk, have signed up with IBM with for blockchain solutions. And I guess it's mostly for traceability, but I might be wrong. There could be an application in much rather greater range. And there's a couple other ports in Europe have already started implementing that. And if you're talking about other industries, that's the payment industry. You're talking about Bitcoin.
Yes.
You know, even though our presentation today is not going to focus on cryptocurrency, but that's the first industry and the most active industry that blockchain technology has been applied.
Thank you. Question from Naomi. How much did return on invested capital improve in the case of shipping industry? And how much is initial investment cost?
Okay, so when we talked about in the shipping industry about empty containers, and we talked about a quarter of all the boxes moving in China, about 30%, 15% in the US are empty and moving on the ocean. So 33% of those costs are actually due to carriers' operational inefficiencies. So if you do the math for any single operator, we can just tell them how do we improve the network. We can't remove the empty box altogether, but this is the cost of the entire industry is 15 to 20% billion a year. So if you can improve by a few single percent, they actually help them to save a lot of money.
But you don't have any quantitative measures as of yet.
Quantitative measures is more on paperless ordering and record keeping, and this is something we also did the math. For example, if each paper processing costs you, like say maybe 80 cents to process, and then you basically times the volume. And if you record everything instead on paper, but on a distributed ledger, then you can calculate the amount that you can save for an operator.
Thank you. Yeah. A question from Rixi. I think it's the last question since we're quite out of time. As data becomes part of blockchain, surely the practicalities of standardizing data is so it is suitable for it will be barriers to entry for blockchain participation.
Mm-hmm. I agree with the issue of standardization, and this is what many different blockchain networks have discussed for a long time, and people raising questions. I would say that standardization will come when their proven networks can process more efficiently and allocate resource better than others. I think it's too early to talk about standardization. But when networks start to prove to work on itself, I think the other network they have to come and sit down and get more inclined. The networks that has less users and is less efficient will have to incline to move to closer to the larger network. I mean, this is like the development of the internet. Standardization is a key issue, but I don't think it's the focus at the time. The focus should be encourage industry participation, and once usage is high enough, standardization will be a natural next topic.
Thank you, Indy, for an insightful presentation. It's great to see real life uses on blockchain. Next week, join us with Gary Delaney on technological change and its impact. A look into how technology is changing the dynamics of exchanges. I wish you all a good afternoon, and I look forward to meeting you next week.